Hello everyone, this is Apoorv Bajaj and I will be teaching the first session in the Edubuk CETA certificate program, which is Certified Emerging Technologies Analyst program, right? So I'll start with the first topic, which is artificial intelligence. Yes, and we'll just start from the first topic within artificial intelligence. We'll just understand the definition first, and then we'll understand the um, basic meaning of intelligence and what is artificial intelligence actually means and how do you judge intelligence, etc. And again, this is a part of our globally award-winning CETA certification program. So basically, let's start with the very basic. What is AI, right? What is artificial intelligence? If I break these two words into the full word AI into two words, artificial and intelligence. So let's break it down further. So an intelligence that is artificially grained into computers or robots, for example, right? So that is artificial intelligence, the intelligence that is not real, that's not human, but ingrained into the computer, into the robots, into the machines by humans artificially, right? So that is the ability. So in definition terms, what is that is? That is the ability of a digital computer or computer-controlled robot to perform tasks commonly associated with intelligent beings. Now, who are these intelligent beings? Humans, right? So we engrave these intelligence to the computer, to the machine, to the computer-controlled robot, and over time it becomes intelligent because we are doing it artificially into the machine. So it's called artificial intelligence. Now, since the development of the digital computer way back in 1940s, it has been demonstrated that the computers can be programmed to carry out very, very complex tasks. For example, just very simple example, right? So think of your calculator, right? Can you perform a calculation like 1, 2, 3, 4 in 2, 4, 5, 6, 7, 8, 9, 10, right? Can you do that, right? Normal guys minus Shakuntala Devi will not be able to do it as fast as a computer calculator would be able to do. Why? Because a calculator, is able to perform this complex calculation by learning each time that one digit multiplied by another digit, right, will lead to what answer. That's why people like, who are very great in mathematics or can do all this multiplication like Shakuntala Devi, they are called human calculators, right? Ultimately, but a calculator is better in performing those complex tasks fast and more efficiently, right? So that's the benefit of AI to aid humans in various tasks, in very simple terms, here in calculation, right? And obviously, in the due course, we'll learn about chat GPT and all that stuff within AI, natural language processing and all that. But right now, I'm focusing on very basics about what is AI. So because this is a fundamental level 1 course of CETA. Now, what is intelligence, right? So before we understand the AI, let's understand first the intelligence part of it, right? So despite, there has been a lot of advances in computer processing speed and memory and capacity, those nano chips and all, there are yet no computer programs in the world that can match human flexibility in daily tasks. So friends, this is a good news. Computers will not be able to take your jobs. They can only aid you, or people who know computer well, how to aid themselves or how to work in tandem with the computers to make the process more efficient and more effective will be able to replace to your jobs, right? But your job will not be replaced by them because there are not yet any computer programs in the world. Even if you use quantum computing, there are no program that can match human flexibility, right? Psychologists in general, how do they characterize human intelligence? They don't do it by only one trait, like just pass this exam, IQ exam, and you are the most intelligent. No, the intelligence actually, when it comes to researching in AI, the basics, how is intelligence being determined? It is determined based on 5 components, a complex combination of these 5 components. What are those 5 components? The first one is learning, second is reasoning, third is problem solving, fourth is perception, and fifth is language. When these 5 things combine together in a very complex manner, that makes a human being intelligent. And when you ingrain this intelligence into computers, that then becomes artificial intelligence, right? So now let us understand, because this is fundamental level of CETA certification program by Edubuk, let us understand first what is intelligence and each of these 5 parameters in next few slides, right? So the first one is learning, right? Components of intelligence. The first one being learning. So obviously there are different forms of learning as applied to AI, but the simplest is very simple that everyone uses in human terms is trial and error, right? For example, a simple computer program for solving a chess problem might try to move things at random until the correct and most optimal move is found. You know, they will place one horse or the elephant going 1 step forward or 2 step forward or left or right until the correct and the most optimal move is found, and hence it learns on its own by those moves once it finds the optimal move, and every time it tries to defeat human by calculating those moves very fast artificially in its by using its computing power, the computer itself, right? Hence usually in the chess problems, the computer, if you are playing against computer, the computer will win because it can generate those moves very fast because it has learned over time the most optimal move. So humans are tend to be defeated by computers when it comes to playing chess with the computers. Now, another example of trial and error or another example of learning is if I am driving, right, and there's a small 3-year kid in the car or 4-year kid in the car, suddenly I stop while driving and there's a red light, and then the light becomes green and I move forward. I do it again. The kid is seeing that action of mine, and the next time, the 5th time I do that, or there's a red light, the kid will start saying, okay, please stop, because we have to stop every time when the light is red, and now it's green, let's move. So then the kid has learned by seeing 4 times that his father is actually stopping at red and moving at green, right? So that's another way of learning, right? So the program on the 3rd bullet here, the program might then store this solution, the computer, the optimal solution while playing chess with the position, so that the next time the computer encountered the same position, it would recall the solution. But humans generally cannot do that because, you know, it has been scientifically proven that we only use 1 to 2% of the brain in our whole lifetime. You know, if we really use our whole 99% of the brain, then, you know, we will be becoming robots or as fast as the computer would be, right? So the computer just stores that position, that solution, optimal solution every time. It would recall the, and then next time it would encounter the same thing, it will recall the solution. So it has learned basically, right? This simple memorizing of individual items and procedures, known also as rote learning, is relatively easier to implement on a computer. And hence, this is one of the steps of being intelligent, learning, but not the only parameter, not the only component. So more challenging is the problem of implementing what is called generalization. Generalization applies to past, like involves applying past experience to similar situation, but not the same situation. There is a difference between similar and same. Same is exact same. Similar is like it, but not exactly the replica, right? So generalizing a move in chess by a computer in a similar position, but not in the same position, is challenging, rather than using the computer just stored that same position every time when it comes, it will take this optimal move. But a similar position occurs, not the same position. Now, what move will it take? The most optimal move to win the whole chess game is very important and is the most next difficult and challenging part of learning. So that's the first component of intelligence, that's learning. Second component is reasoning. You know, now reasoning meaning, like, you know, to reason is to draw inference appropriate to a situation, right? To any situation, what is the inference out of this? Now, let me tell you this by giving you 2 examples, right? One, the first example is Sachin. He must be either in the museum or in the cafe, right? What does this statement mean? And I go to the cafe and see Sachin is not here. That means if Sachin is not here, because he told me, or the statement says, Sachin is either in the museum or in the cafe. If he is not in the cafe, then he has to be in the museum because he's in either of these 2 places. So I'm drawing inferences by getting into the situation, right? Another example is previous lab accidents of any sort were caused by instrument failure. a test tube failure or whatever. Therefore, the next time any accident occurs, the lab assistant might think, oh, maybe the instrument failed again, and that's why the another accident in the lab has occurred. So that is another kind of reasoning, right? So first is he must be here or there, and if he is not here, so he must be there. Second is because this has happened in the past, and the same thing has happened now, and because the past thing occurred due to this reason, this particular situation would also have occurred due to that same situation. So that's the second type of reasoning. So till now we have understood intelligence and learning, the first component, and reasoning, the second component. Now we'll understand the third component, which is problem solving, right? So problem solving, particularly in AI, may be categorized as a systematic, right? Systematic, like doing it in a very orderly manner. Search through a range of possible actions in order to reach some predefined goal or solution, like in the game of chess also, right? If you want to do any move, my main goal is to win this chess game, right? Or to be at a position where I can create a check and a mate situation, right? So that is my goal. And how should I move systematically, orderly to achieve my larger goal? That is a problem-solving way of doing things, right? Problem-solving methods divide into, again, spatial purpose or general purpose. A spatial purpose will be a very tailor-made for a particular problem. For example, solving a defense problem would be different than solving a general attack problem, right? Even in cricket, I'm saying, let's say cricket as a game, right? Like if you have to defend against a spinner or you have to attack against a spinner, those two are two different techniques, right? How do you defend is different. How do you attack, right? So that's the problem solving. So you should be understanding what's your larger goal and accordingly systematically move and make your actions to achieve that larger goal. Now, in contrast, a general purpose method is applicable to a wide variety of problems. The problem, for example, in the case of robot, right? So, or when we walk, either we can move forward, we can move backward, we can move left, we can move right, or we can jump, right? Is there any seventh way? You can go up, go down, go left, go right, go forward, go back. If you teach the same steps to the robot, generalizing it, right? You pick up, you put down, you move forward, you move back, you move left, you move right. If you can ingrain that knowledge into the robot of all these 6 steps, one by one, with the larger goal in your mind, that okay, the robot has to pick this particular bottle, whatever the thing, right? This is the bottle, right? For example. So if you have to pick something by the robot, then this action, you move forward. You'll 2 steps forward, move 1 back, move 2 steps left, move 1 right, and then pick up the item and then drop it down, put it down until the final goal is reached. So that's how you, in a problem solving manner, you teach the robot in an AI scenario that how to do a certain task using these 6 actions. Now, the 4th component of intelligence is perception. Now, in perception, like as the dictionary meaning would also mean, the environment around us is scanned by various means of sensory organs, real or artificial. In the case of computers and everything, it's by sensor, the IoT sensors or Internet of Things sensors or electronic sensors, right? And that scene is then decomposed into separate objects in various spatial 3D relationships. Now, to simplify it further, it's basically how you sense your surroundings in a 3D manner in a computer-aided design, using a CAD or a CAM kind of thing. So analysis is complicated by the fact that an object may appear different depending on the angle exactly from which it is viewed. Is it a top view? Is it a side view? Is it a rear view? And the direction and the intensity of light in the scene, and how much the object contrasts with the surrounding field. For example, camouflage. Who does a good camouflage in the real world? Probably a caterpillar or or even military people, right? When they go for a fighting or something, then they wear the clothes that is similar to their surrounding, like green and brown, because usually they fight or they have to defend their countries in a scenario where they have a lot of land and the trees around it. So they also for a camouflage wear those green and brown kind of clothes, or green and brown kind of nets, so that you can camouflage the perception. You can change of your another party that this is just a tree or a land rather than a human itself. So perception is basically the environment around you. You sense it, you break it down in a 3D manner, and then you decompose it, and then you and this depends on a lot of things like direction, intensity of light, and all how the object contrasts with the surrounding field and all. So that is a perception. That's a fourth component of intelligence. So till now we have studied perception, problem solving, reasoning, and learning. Right now I'll go to language. So a language is another very key component of intelligence. Right? It's a system of signs, sign language, also having meaning by convention, for example, right? So language is not always spoken word, right? You have different languages in the world. You have English, you have Hindi, you have Jewish, you have Spanish, German, a lot of languages, right, in the world. So we communicate by language, and that's also how we communicate intelligently within our tribe or within our community. But the language can also mean some symbols, right? Like those traffic signs. For example, traffic sign like this. What does this mean, right? There's some hazard ahead. Go ahead carefully, right? There's some hazard ahead, maybe a broken road, or people are working on the road in the construction area and all. So those kind of things. And then there are a whole lot of traffic signals, and also a lot of things that are not spoken also can have meaning just by the symbols and that language is, right? Now, hence, finally, just to come to an end of this first topic within the AI, what is intelligence basically? It's a complex combination of 5 factors that we have just discussed: learning, reasoning, problem solving, perception, and language. Now, finally, I would like to conclude this particular first topic within the AI series of Edubuk. To use these 5 parameters in a complex combination by humans to teach computer or a machine or a robot, right? And in the process make it intelligent is, in simple terms, artificial intelligence. Isn't it easy, right? That is what is, in very basic simple terms, artificial intelligence, right? So this was the first part of the AI series within the CETA certification program of Edubuk, that we have focused on artificial intelligence. Within that, the first topic, what is AI and what is intelligence? Within this AI series, we have more like 15-20 more videos upcoming, and then the full topic of fundamentals of CETA, fundamentals of AI will complete. And this is a program by a globally award-winning Edubuk, CETA, which is Certified Emerging Technologies and Analyst. This is the first of its kind globally award-winning program that we have started, where you can understand the fundamentals of 9 emerging technologies like AI, blockchain, cybersecurity, cloud computing, IoT, Internet of Behavior, Metaverse, augmented reality, virtual reality, right? Metaverse, AR, VR, and obviously 3D printing. So all these, robotics, drones, all these technologies, we will be teaching you fundamentally in this course, and then we will be taking the exam, one final exam, and then you will be getting the certificates recorded on the blockchain. And we have got our own tie-ups with the corporates where going forward you can be hired by them given your performance in the examination and everything. So this is the first part of the CETA level 1 exam, AI. Within that, the first topic, what is artificial intelligence? Signing off, Apoorv Bajaj from Edubuk. Thank you so very much.